All right, good morning. Welcome back to Elements of Calculus 2. I'm going to double check to make sure I'm recording here. It is. All right, so the next problem we have here is an improper integral. So there's an infinity here. Okay, your book generally does type 1 improper integrals. I'm not going to spring a type 2 on you. It's just got a discontinuity hidden in the middle of it, but we're not going to do those. So what I'm looking for here is, first off, could you integrate this? But this is a fairly straightforward integral because what I'm really grading you on is, do you remember the notation that we have to use here? So the first thing we're going to do is we're going to say, pick a different letter, limit as t approaches infinity, okay? And we're going to say 0 to t of x over x squared plus 1 dx. Okay, and we've got to pretty much keep this piece like the whole time. Okay, and I'm sorry that that's the way that this kind of problem works for us. And in this class, this is where you learn how to do this, and we have to be sticklers about making you guys do this. After you get done with this class, you are free. Nobody's going to come back and penalize you for doing this because nobody goes back to do this. But for this class, please make sure you're typing in the limit, you're changing the limits of integration so that you are not putting infinities or discontinuities inside of your integral. And then we can go ahead and move forward. So this looks like a u substitution. So we're going to go ahead and say let u equals x squared plus 1. That should be a plus here. Now, we're going to do a couple of things after this point. First thing, as soon as you make a substitution in calculus, take its derivative. Okay. The second thing I'd like to do is say, okay, when x equals 0, u is equal to 1. When x goes off to infinity, limit x goes to infinity of x squared plus 1, then u also tends towards infinity. Okay, so we just changed the limits of integration to make sure that we're going to be dealing with the u world values rather than the x world values. Okay, so I'm going to go ahead and insert a little 2 over 2 here, just so that I've got my dx and my du kind of sitting here waiting for me as I'm going to go ahead and make my substitutions. So let's go ahead and do that. So we still have a limit as t goes off to infinity because this didn't change. Integral from, this did change, 1 to t, okay? So we went from 0 to 1 in the u world. The x world doesn't have it. The x world goes to 0, but we're now in the u world. We're going to 1, starting from 1. Again, going off to t. We have 1 over, what was x squared plus 1? That was just going to be u. And my du was this whole 2x dx. So we're going to have a dx here, du rather. And I've got a 1/2 out front, because I usually like to put my constants out in the beginning here. This isn't too bad of an integral, right? We're going to have limit as t goes to infinity of 1/2 natural log of absolute value of u. Again, going from 1 to t. Now, one thing I'd like to check out here is u was x squared plus 1. That's always a positive number. You don't have to include absolute values when it's always going to be positive. Okay, x squared plus 1, u squared plus 1 rather, always going to be positive. So we're going to have limit as t goes off to infinity, 1/2. And here we're going to have limit of t minus natural log of 1. Parentheses around this, and we'll go ahead and sort this out. Now, natural log of 1 is 0. So we just have 1/2 limit as t goes off to infinity, natural log of t. Natural log of t as t goes off to infinity is also infinity. Remember what the natural log graph looks like? Something like that. So it's too steep, but it still looks something like that. So as natural log goes off to infinity, or as t goes off to infinity, natural log goes off to infinity. So this thing goes down to, this is what they call a divergent integral. Okay, so your answer for this one is going to be that the value for this integral diverges. Okay, that's all we have to do at that point. We evaluate the limit, we noted it diverged. What I'm rating you on is, did you rate the limit every time you did the problem, every time you did the line. So be careful about that. I'm just going to warn you, like, hey, that's something I look for this particular class. Um, and it's something you have to watch out for. So be careful with that. Make sure you're doing your notation properly. And if it diverges, then so be it. It diverges. But thank you very much for watching the video, and I will see you in the next one. And say, oh, I don't want to stop and exit.